All right, ladies and gents, we're talking today about the number e, okay? In your calculator, if you hit pi, you get 3.1415, E is another number that's in your it's programmed in your calculator. It is defined by the value 1 plus 1 over n to the n power. All right, this is an idea that's derived out of calculus. I know a lot of you are like, what? Okay, just tell you where the number came from. It is an exponential function. If you look at your calculator, on your calculator, you'll hit, does everybody see the ln button? That's natural log. We'll talk about logs later, tomorrow. But you see an e to the x. It is an exponential function. The variable is in the exponent. You're just using, the base is the e. It's always going to be the 2 point whatever. Here it is, 2.71828. It's just like pi. It's an irrational decimal number that is already programmed into your calculator, and we use it for different things. All right, so this is what it looks like. It's the natural exponential function. It's on the ln button that goes with the natural log, but this is just an exponential function. Do you see the variable up here in the exponent? Right, that's what makes it an exponential, like we talked about yesterday. Your graph looks very similar to our exponentials that we did yesterday. Your parent graph for e to the x is in between 2 to the x and 3 to the x, because e is a little bit bigger than 2, but it's smaller than 3. So that's where that comes from. Now let's practice this, please. Everybody with me. In your calculator, you have e, and then a little caret comes up, and then put it into the third power. Go ahead. Put that in your calculator. If you don't have one, sit and look around. Look at somebody next to you. We're going to round to 5 decimal places. All right, we got 20.08554. It's 5536. So you will be told what to round to. Yeah. All right, look at the next one. In your calculator, you need to hit 2. Then the E button, then you raise it to the negative 0.53. Guys, remember, the negative is not the same as the minus sign. You have to use the negative. All right, what'd you guys get? 1.17721. In your calculator, the next one, E to the 4.8. Go ahead and evaluate that. Tell me what you guys get. 121.510. 41, like that? No, that's fine. All right, guys, I cannot impress upon you enough the importance of being able to use your calculator. All right, this book, believe it or not, was written before COVID. So this word problem was just a fictitious word problem about an infectious disease that began to spread in a small city. Kind of creepy. But they will give you the equation, right? This is the equation here. And they're asking you 4 different questions here. A says, how many people are initially infected? So where T is 0. Then they want to know the number of people infected after 1 day, 2 days, and 5 days. If they give you the formula, this should not be too difficult for you guys to figure out, but it's all going to be how you enter it. So if I'm going to find A, how many people were initially affected, you need to put 10,000. If you're going to do all this in your calculator at one time, this is how you need to enter it. 10,000. Then you have to hit divided by, then you have a parenthesis. 5 plus 1245. Hit your E button. Then when it raises the E, a parenthesis will come up. You have negative 0.97 times 0. Close that parenthesis. Then you have to close the whole parenthesis on the bottom. So just like we did yesterday with our interest formula, we have that double parenthesis. You guys have to do the same thing here. You have to tell the calculator to do everything in the bottom and then do 10,000 divided by everything in the bottom. So try doing that right now. Tell me what you guys get. Your answer is 8. When I did this last period, nobody answered this because they were waiting. They were like, there's no way it's 8. Because I put in this big formula with this weirdo numbers and I got 8. Okay, so let's think about it, guys. Look at the formula itself. When I plug in 0 for t, look. When I plug in 0 for t, what happens to the whole exponent? It becomes what? It becomes 0, right? Anything times 0? And then what's e to the 0 power? 1. So what essentially is happening is you're having 10,000 divided by 1,300. 5 plus 1,245? Not 1,300, it's 1,250. But it's just 10,000 divided by 1,250. That's what that works out to be. Now, your next ones are not going to be like that. We're going to do this problem now 3 different times. We're going to do it where t is 1, when people are how many people are affected after 1 day, how many people are affected after 2 days, and then how many people are affected after 5 days. So we're going to practice. Again, this is just practice. Put this in your calculator. It's 10,000 divided by, and then you have 5 plus 1, 2, 4, 5, e, and it's going to be raised. Make sure you have that in parentheses. To the negative 0.97 times 1 power, and then close that parenthesis. Then you're going to do it again, but you're going to plug in t is 2. Then you're going to do it again, and you're going to plug in t is 5. So let's go ahead and do that. Now remember, this is a word problem. We're talking about the number of people affected after a certain amount of days. So we should round to a whole number. Right? So if there was 8 people initially infected, how many were infected after day 1? What'd you guys get? Try it again. When you plug in 1. 20.9. So about, we'll say about 21 people. Okay. What happens after day 2? About how many? So about 54 people. Okay. What happens after 5 days? About how many? About 678. Guys, we're talking about the span of 5 days. Look how quickly that exponential function grew. It went from 8 to 678 in 5 days. That's what exponential functions do. They start off slowly, and they either increase very quickly if it's a growth, and they decrease very quickly if it's a decay. Does everyone see that? It doesn't go up the same amount every time. Something that grows exponentially, it doesn't multiply by 2 or multiply by 3. That's why the variable is in the exponent. So we need to be able to read a word problem, understand when they talk about time, where that would go into, like for this case, where that would be substituted into your variable, and then be able to answer the question correctly. You guys got me? All right, now let's just look. Yesterday we had the interest formula, and we talked about how the interest was compounded, right? Quarterly, monthly, yearly, daily. Well, today we're going to talk about interest again, compounded, but there's a specific way that this is compounded, and it's continuously. You guys should have learned about this last year. You should have seen this in Algebra 2. We definitely went over it in pre-cal, for those of you who had pre-cal last year and then came to college algebra this year. You will see it again next year. But when you have compounded interest that is continuous, you use this specific formula. And I always say it's my friend e.mp4. Everything from yesterday is the same. Principal is still the initial amount you start off with. Your interest rate still has to be written as a what? Yes, good. Has to be a decimal. And your time is still in years. Just the thing that's different here is we don't have an end. We don't have a monthly, a quarterly, a daily. As soon as they say e.mp4, you go, oh, I have to use the E. As soon as they see continuous, I have to use the E. So you'll have a question that looks just like it did yesterday. But I see it says compounded continuously. So immediately I said, oh, it's my friend e.mp4. What is the principal? What is the amount that I initially invested here? $1,000, good. And I have my E, and I'm going to raise it to, what is the interest rate? 12%, so that's 0.12. So 0.12 times how many years? 3 years. Do that in your calculator, guys. 1,000 E, and then make sure your 0.12 times 3 is in a parenthesis. What do you get? 1,433. And how many cents? 33 cents. Okay, guys, very important, right? We're all in high school. Some of you have cars. Some of you talk about buying cars. You would never go to a car dealership and be like, I'm not spending more than 13067.93 cents dollars, right? Okay. When we're talking about our interest formulas, we need to be able to read the number, and we're talking in dollars and cents, so 2 decimal places. You with me? So let's just do some practice. Let's do some practice here. I want you guys to practice with our calculators. Let's do number 2 right here. We're going to evaluate number 2 with all 4 of these values. F of -1. When I plug -1 into my x, so in my calculator, I'm hitting 3, E, and then that little caret button comes up, and in parentheses, I have 0.43 times -1. Close your parenthesis. Remember, that's a -1. It's not a -1. So you want to use the negative sign and not the minus sign. What do you guys get? 1.9515. So something around 1.95. We're just practicing in our calculators here. So now we're going to evaluate, and I'm going to use 1/3. Now, again, the reason we're doing this is to practice. You guys, when you have a fraction, you need to put it in parentheses. So you would, in your calculator, hit 3E. Then your caret button comes up. So you have parenthesis 0.43 times, watch, parenthesis 1 divided by 3. You have to close that parenthesis and then close the whole exponent parenthesis. You'll have a double parenthesis there at the end. All right, so everyone's getting about 3.46 or so. Okay. All right, now let's evaluate with the square root of 2. So F square root of 2. I'm plugging in the square root of 2. So I have 3E, and I'm going to raise that to the 0.43 times. Now hit second x squared. When you hit second x squared, then your parenthesis with the root should come up, right? So then you have to put the 2 there. You got to close that and then close the whole exponent. You got another double parenthesis. But when you hit second x squared, that's how you get to be able to put in the square root of 2. So what'd you guys get? So you guys are getting about, tell me again? 5.51? Okay. Now, if you were going to evaluate number 5, you'd have to put negative and then 1 divided by 4, parenthesis, then hit the E and then plug in. I cannot impress upon you enough how important the parentheses are. Super duper important, okay? So if you have a question like this last interest question, there's 2 of them that would use yesterday's formula, and there's one that would use today's formula. Which one uses today's formula? The last one, continuous. When I see continuous, I immediately think, ooh, APERT. Now, when I do all 3 of these, when I evaluate, the answer should be very similar. But in all 3 of them, guys, my principal is how much? How much do I start off with? $13,575. What is the interest rate that I am compounding at? 0.0535. Yep, 5.35%. Even though there is a decimal in that number, I still have to move it. And then what is the time I'm talking about? 6 years. So the thing that's going to change is when I do quarterly, what is my end value? How many quarters are in a year? 4. When I do daily, how many days are in a year? 365. So we're going to evaluate all three of these with the exact same numbers, except I have to figure out which formula to use. So in this first one, I have my principal, which is 13,575 times 1 plus, and here I have 0.0535. When I compound quarterly, my 4 is underneath there, and I'm going to raise that to the 6 times 4 power. If you want to put in, instead of 6 times 4, 24, that's fine. When you plug all that in your calculator, guys, remember that fraction right here has to have its own parenthesis. And then you got to close it. But what do you guys get? Okay, tell me again. You got 18,673.
And then 44 cents.
And 44. Okay. Agree or disagree, peeps? All right, let's do the next one. Instead of compounding quarterly, I'm going to compound daily. So I have 13,575. I still have the same amount that I put in. I still have my 1 plus. My interest rate stays the same, 0.0535. But instead of 4, what is daily? What number do I use? 365. Good. So remember, close that parenthesis, close the whole parenthesis, and then you have to raise it to the 365 times 6. If you don't put that 365 times 6 in parentheses, you will not get the right answer. But when you do that, ladies and gents, what do you get? Okay, 18,712 and 77.
Yeah.
Is that a huge difference? No. Did I tell you guys yesterday when you do these problems? Should there be a huge difference when you are calculating quarterly versus daily versus monthly? No. So make sure of that. Some of you are catching your own mistakes, and it's good. You're investing $13,000, and then you're saying, well, at the end of 3 years, I have $1,000. Well, unless you're doing something where you're losing money, that's not what a savings account that accrues interest should do. So just pay attention. The last one says continuous. So instead of the formula that I used yesterday, when I have continuous, I'm going to say, okay, well, I have my initial amount, my 13,575. Continuous means a per. So I have E, and I'm raising that to the 0.0535 times, how many years was it? 6. And tell me what you guys get. So we get $18,713 and how much? 21 cents. Again, is there a huge difference between these three answers? No. There's a matter of it's less than $10. Right? I mean $100. When I say 10, I didn't mean 10.
What's the formula for the other one? For the daily?
That's what we did yesterday. When it's compounded interest quarterly, daily, monthly, yearly, semi-annually. The only time you use a per is when you have continuous. N is how the interest is compounded. How interest is compounded. Meaning, is it monthly, quarterly, daily, yearly, semi-annually, something like that.